Today we're going to discuss Newton's third law. Newton's third law is also known as action-reaction. Every action has an equal and opposite reaction. So these phrases go together. When we talk about Newton's third law, we're talking about the forces acting on two different objects. This is where it's different from balanced forces. Balanced forces are talking about the forces acting on one object. When we discuss Newton's third law of action-reaction, we're talking about the forces acting on two separate objects that interact with one another. Every time one object exerts a force on another object, the second object exerts a force that is equal in size and opposite in direction back on the first object. So if you say, I push you, even though you don't push back, you push me back equally in the opposite direction. So for every action, there is an equal and opposite reaction. And there's a couple of different examples that will hopefully help you get the gist of this and understand what we're talking about here. Think about a rocket taking off. The rocket is sitting on the Earth, and the rocket has a specific mass. And its mass is much less than the Earth's. But when that rocket ignites its thrusters, the exhaust pushes down on the Earth with, let's say, 1,000 newtons of force. The Earth pushes back on the rocket with an equal amount of force, 1,000 newtons. The rocket starts to move because it has less mass. So you'll see it start accelerating away from the Earth. Once it's in the air, it's a slightly different story where the thrusters are pushing on the air and the air is pushing back on the rocket, because air has mass as well. But at liftoff, at launching time, the thrusters from the rocket are pushing on the Earth, and the Earth is pushing back on that rocket to accelerate it upward. Another example, if you were wearing roller skates, let's say we have two students, and they have roller skates on their feet, and they're facing each other, and they push each other. If they have equal masses, so if they have equal masses, when they push each other, they will move in the opposite directions. So if student A pushes student B, if they have equal masses, they will move in opposite directions at the same rate of acceleration because the force applied is equal and opposite. So let's say something like this. If we have two little cars, if we have car A and it weighs 10 kilograms, and we have car B and it weighs 10 kilograms, and we put a loaded spring between them, and we squish the spring down as far as we could, and then we release the spring. They're both going to move in the opposite directions at the same rate because that force is equal and opposite. Think about it like this. If you push somebody, they're pushing back on you just as hard. All right, if you're sitting in that chair, you're pushing down on the chair is pushing back up on you with an equal and opposite amount of force. So that's Newton's third law. Action-reaction. Something pushes it pushes back equally as hard. If you kick a soccer ball, you kick that soccer ball with your foot hits that soccer ball hits your foot back with the same amount of force that your foot hits it. Notice we're talking about two objects in all these different scenarios. In this scenario, we're talking about two students. In this scenario, two cars. In our rocket example, we're talking about the rocket and the Earth, the soccer ball and the foot. So Newton's third law is different from balanced forces because they're acting on two different objects. If you have any questions, please feel free to ask us in class as we walk about the room, and we'll be happy to help you and try and explain some of the concepts to you, okay? Have a good day.